about debugging, which is really quick and it's more of an art than a science, as you'll very quickly see. We'll talk about control flow or basic logic and programming, and then we'll also talk a little bit about booleans, which relate to the logic flow as well. Okay, so to start off our section on debugging, the one thing you need to know in terms of kind of like best practices around debugging is just that developers spend way more time debugging than they do writing new code. In most cases, like I said, I think on the first day, if you were to break out the ratio of the amount of time someone spends writing new code versus reading existing code and fixing code that they've written, the writing new code probably takes somewhere around a quarter to a third of the time, right? And all that means is the majority of the time people are actually spent fixing code and trying to understand if the code works, why or why not. And debugging is not a reflection of how good you are as a programmer. Generally speaking, whenever most programmers write code, the first time you run it, you expect it to maybe not work, right? Like that's kind of something you brace yourself for because there's so much complexity, and a lot of times when you run into errors, it's not because sometimes it's very very simple stuff, but other times it's problems that you're not going to realize you have until you kind of get there. And so debugging once again is more of an art than a science. You'll get a lot better at it as you program more and more. Today, we're just going to talk about two very, very obvious errors that we see kind of pop up when people are first starting off learning programming. But before we get there, most in most coding environments that you work on, whether it be in CodePen or where else where have you, generally speaking, with HTML we talked about how it was very forgiving, and if you had an error in HTML, the computer would just try to run the code, and it will look really bad, but it wouldn't tell you that hey this is wrong, right? Because to a computer it doesn't quite know with HTML like kind of what's wrong. Um, with JavaScript, however, it's the opposite. If you write code that has like very core issues, as in you miswrite syntax, or you forget how to close, or you forget closing a curly brace, JavaScript will actually not run the code. It will just say, "Hey, look, there's an error here. Please fix it before I continue running on." And so, whereas the errors in HTML were not blocking, in JavaScript they are blocking. And so, in most coding environments, when you do run code, um, especially when you run tests, um, not only will the JavaScript environment usually tell you that there's an error, it will actually tell you what the error is, and more importantly, it will provide the stack trace for the error. This the stack trace can best be described as basically if you were the computer, the stack trace provides all the steps the computer took to get to that error, right? So the computer will say, okay, I tried running this line of code on this page, which then led me to run this line of code on this page, which then led me to run this line of code on this page, and then bam, that's where the error happened, or that's where I couldn't continue on anymore because of some error in the code. If you look at the image on the right hand side here, um, we don't need to talk about the error exactly, what reference error is right now. We'll talk about it on the next page. But just know that on line 4, we have this simple sentence that says reference error, sum is not defined. Okay, that's the computer telling us, hey, when I tried running your code, this is the type of error I got. In this case, the test also said that this is the error that we got, right? We expected sum to be a value, and it's clearly not defined. That's good, right? Because that tells us kind of what type the error is. But notice on lines 5, 6, and 7, there's a lot of text there. But all that's important to really kind of highlight from all of that is those are the steps the computer took to get to the error. And so when we say a stack trace, usually that's what we mean, right? Those are the lines of code that the computer tried running, and they kind of highlight at what point they actually hit the error that you saw in your code. Generally speaking, the way that the stack traces show is it shows the most recent line at the highest level, then it shows the most second recent line and the next line, and so on and so forth. And so in this case, if line 4 is the error, then line 5 is the last line that they ran before it got to the error. Line 6 is what triggered line 5 to run, and then line 7 is what triggered line 6 to run. Generally speaking, when people triage these types of errors, they'll probably look from the most recent line first and see if they can decipher anything meaningful from it, and then they'll work their way down further and further and further. So now we see how the stack trace gives us not just the error itself, but it kind of tells us which files or lines of code are right to get to that error. On line 5, if you look after the localhost and those 4 numbers, you'll notice that there's a colon after it, right? Followed by the number 11, and then another colon followed by the number 7. Those 2 numbers are actually fairly important. Actually, the first one is probably more important because right now, after those numbers, it says only odds.js colon 11 colon 7. What that tells us is only odds.js is the name of the file that was last run in order for us to get to the error. So now we know what file is actually producing the error. And it might sound silly now because you're saying, well, I'm running a single line of code. Like, of course, is this file. But think about running like a web app, right? Where you have dozens of files or hundreds of files. It actually becomes very important for us to know which file kind of is triggering the error that we're seeing. So that's useful. But after that file name, we have a colon. And the first number after that colon is actually the line number that the error ran, the code encountered. Once again, if you have a very short snippet of code, it may seem very trivial, but if you have a page of code with hundreds, if not thousands of lines, that line number becomes incredibly important, right? Because now, rather than just knowing that, generically speaking, something in this massive page of code is broken, we now have a line number that tells us kind of where to start looking. And then last but not least, the second number after the colon is the character number. So this is saying line 11, character 7. Generally speaking, the character is probably not as important. I think once you know what line it is, it kind of sets you up well to investigate. Now, this may seem like a very great tool, and it is, but it's not a catch-all, right? A lot of times, the errors that where the error occurs may not be where the error is being caused. So, for example, let's say there's a car crash, right, and the airbag doesn't open. Well, we notice the airbag doesn't open at the point of crash, but that's probably not where the quote unquote that's not probably not where the manufacturing issue occurred. The manufacturing issue probably occurred in a factory somewhere else. And so notice how when JavaScript tells you there's an error, it'll basically what it really is telling you is, hey, I tried running this line of code and I wasn't able to run it successfully. Right? Take a look at it. It doesn't mean the error is there. It just means the error manifested there, right? And so even if it's not the exact line where the error is, it at least gives you a place to start investigating and working backwards and trying to see, okay, what happened? How do I think about where the error is, etc. And then last but not least, if you come across an error you haven't seen, feel free to Google it. I guarantee you someone else on the internet has already encountered your error and probably can at least give you some context for why that occurs. Like I said, for today, we're doing super basic types of errors here. And the 2 basic error types that we'll probably see when we do some of the simpler workshop problems are, the first one is syntax errors, right? These are things in which you have a misspelling or a typo or some other kind of syntax that essentially makes your code not valid JavaScript. Something like forgetting the semicolon at the end of a line. Yes, it's best practice, but your code will not, in 99.9% of cases, your code will not run because of it, right? When we say syntax errors, what we're talking about are actual errors that block your code from running. So this is like if you have an open parentheses somewhere, but you forget to close it somewhere else, right? Like that's a blocking error. JavaScript will see that code and say, look, I have no idea the logic behind which I'm going to execute this, so I'm just not going to execute it, or I can't execute it. And so the first thing is making sure that all of your braces, brackets, and parentheses are appropriately open and closed, and they match up. Once again, having your code being properly indented goes so far in making this and helping you kind of identify these errors quickly. And the second one is just making sure that your commas, semicolons, and arrows are also properly being used. Like I said, these things come more with practice. And when I say semicolons, I don't mean semicolons at the end of the lines of code, because what I'm talking more about is like if you write a for loop, for example, that requires semicolons, right? If you forget one of those, then JavaScript will not run and say, hey, please fix these errors. The other type of error that you'll likely encounter is something called reference errors. And this basically means you're trying to use a variable that doesn't exist. This can happen a variety of ways, including something called scoping. But more often than not, when you're first starting off, the most common reason for why this error happens is honestly just misspelling the name of a variable. If I have a variable called car, say let car equal something, right, and it's spelled CAR, and somewhere else when I try using it, I use a variable CAD. Well, JavaScript isn't smart enough to know, like if there's only 2 variables on the page, clearly I meant to use car. It will just say, oh, you want to use a variable called CAD? I looked on the entire page for it, couldn't find it. So, you know, I'm going to give you an error saying you tried using a variable that doesn't exist. And so if you ever see someone telling, or not someone, whenever you see the computer telling you, hey, this is a reference errors, as a first rule of thumb, just make sure that you're spelling the name of the variable right. And then later on, as we get into more advanced topics, we'll also talk about other reasons in which that error may occur. Okay, so this by no means, right, this is barely scratching the surface of the various types of errors that you come across when you program. But debugging is more of an art form than a science, quite honestly. And over time, as you code more and more, you develop a pretty good intuition for, if not knowing what the errors are, at least knowing how to start looking or how to start investigating the errors. Yeah. So this is all. This is as much as we're going to talk about it. But are there any basic questions before we move on to control flow? Everyone good? Okay. All right, then let's move on to the next topic, which is conditional statements. Okay. Conditional statements are an example of our control flow. What's a control flow? A control flow is basically a process or a flow through which we make decisions. So conditional statements is an example of a control flow. And you can think of a conditional statement as if it was a fork in the road, right? So the simplest type of conditional statements is our simple if-else loop, which we see there on lines 4 through 9, right? If we think about, like, even just in normal human English, right? Like when we say things like, if this is true, do this, else do this, right? What is that really kind of asking us to do? Whoever's listening to that, what it's telling us is you have to make a decision. You can do one or the other, and I'm going to give you a basis on which to make that decision, right? Like, if this is true, do this. If this is not true, do that, right? So I'm giving you two options. I'm making you pick one of those two decisions. But what implicitly in that is also what we're also saying is you can't do both things at the same time, right? And so now you can kind of see we're starting off with this pattern of saying, before, every single line of code we wrote on a page got run. But with the conditional statements, we're slowly migrating into a world in which, hey, some of the code some of the code that we write may not be run, or may not have to run if there's no need to run it. Okay, and so when we look at line 4 there, we have a simple if loop, right? We have the if and also else, which are both reserved words in JavaScript, which means you can't have variables called if or else. We have a parentheses after if, in which we contain something called a conditional statement, and we'll talk more about that when we talk about Booleans. But essentially, what an if statement is saying is, if whatever the thing in the parentheses becomes true, or if that statement is true or it's correct, then we have an opening curly brace on line 4, and we have a closed curly brace on line 6, and we have a block of code in between, in this case just line 5, and that block of code will run if this true statement inside those parentheses is true. Otherwise, we move to line 7. Notice how we have an open curly brace and then a closed curly brace on line 9. Otherwise, we run the code in between those two curly braces. So in this case, we run line 8. And so line 4 is saying if and the thing in between the parentheses is true, which it is actually the true value, then we will run line 5. And that's it, right? Like, imagine if I was telling someone, like, hey, pick a ball out of a hat. If the ball is red, go buy me a soda. If the ball is blue, go buy me a hot dog, right? In that scenario, the person would come back with either a hot dog or a soda. They wouldn't come back with both. Same thing here, right? In the if-else statement, once again, the crux of this is saying that if whatever inside that if statement, that if thing on line 4 is true, we'll do line 5. Otherwise, we'll do line 8. There's no scenario in which we will ever run lines 5 and 8 simultaneously, right? We're being forced to make a decision. And so if we were to kind of diagram this out, if we look at the top half of the page, right, in the gray box on the left-hand side, we have our if-else loop. And notice how things are properly indented, so it's actually pretty easy to read. right? We see the if statement in the first line. We see the closing curly brace, the else, and the other closing curly brace. And so we have two lines of two kind of blocks of code, right? One that console logs out this is true, and one that console logs out this is false. Okay. And in our if statement, what we're checking to say is if 9 is greater than 8, console log out this is true. Else console log out this is false. Okay. Well, that begs the question: is 9 greater than 8? And the answer is yes, it is. So then we console log out this is true, and we skip the rest of the if-else loop because we found our true condition. We don't need to check anything else out, right? If, however, if that statement I read, if 9 is less than 8, well, is that true? No, it's not true. So then we go to the else statement and we console log out this is false, right? And so to make it a little bit more easy for you in the graphical form on the right-hand side of the page, right top hand side of the page, right? We have our box, is 9 greater than 8, question mark, is it? If it is, then we go to the left-hand side. If it's not true, then we go to the right-hand side. And so once again, right, we're making you make a decision about whether or not to do one thing or to do the other thing. Does that make sense to everyone? Or rather, are there any questions around that? Okay. So then let's move to the bottom half of the page, okay? Now we get a little bit more involved, right? Because if you think about in the real world, we have a lot of either or decisions, but we also have like a lot of sometimes more complex, right? I'm trying to think of an example, right? Like, if I'm thinking about my lunch decision, right? If I want a burger, I would go to this place. Else, if I want Mexican food, I would go somewhere else. Else, if I want Italian food, I would go somewhere else. Right? Like sometimes there's more than two choices the way to pick, and so that's where JavaScript kind of comes in handy with this else if statement. Once again, right? JavaScript is written to somewhat read like a human, the way a human would talk, right? And so if we think about if, else if, else if, else, like these are all things that kind of happen somewhat sequentially, right? And so here, if I look at the code on the left hand, now we're on the bottom half of the page. The first line says, if num is greater than 8, console log out num is greater than 8. We don't know what num is, so we can't make a decision just yet, but we know that that's what the loop is telling us to make a decision, right? If num is greater than 8, then we console log out num is 8, and and then we skip the else if and the else because we already found our kind of true condition, right? However, if num is not greater than 8, then the next thing we check is else if num is greater than 6. If it is, then we console log out num is between 6 and 8, or greater than 6 and less than 8. And then we have one more else, then we console log out num is less than 6. And so we follow the diagram on the right-hand side. We're sorry that it didn't come out as perfect as we wanted to, but if you just follow the arrows a little bit, at the very top we have a num is greater than 8 question mark. If it's true, we do this thing. If not true, we do this. We print. If not, then we actually make this other check, right? The other check is saying if num is greater than 6 question mark. If that is true, then we print out one thing. Otherwise, we print out this other thing. And so even though this may seem a lot more complicated, realize that it's not, right? Because if num is not greater than 8, if not true, those three boxes on the bottom here, those are just another if-else loop, right? And so whenever we write these, and you can have as many else's as you want, right? So we say if num is greater than 8, else if num is greater than 6, else if num is greater than 4, else if num is greater than 2, and so on and so forth. We can have as many options as you want. We can be as granular as we want. But just note that granularity means we always check the first thing first. If that's not true, then we check the next thing. If that's not true, then we check the next thing, and then so on and so forth on the way all the way until we get to the very end, right? That's one of the things I think people kind of really get hung up on is they think that when you see an if-else loop, if-else-if loop, they think that we check everything simultaneously. But the point is still that we still check in order from the top on down. And then lastly, and this is just a reminder because I know folks in the previous class kind of had a few struggle with it a little bit. If I say, if the ball is blue, do this, else do that. Well, The else kind of implies that as long as the ball is not blue, you do this thing in the else, right? And what that means is else does not need an explicit condition, because else by definition just means, hey, the if condition was not met. And so that's why after if we have something we're checking in the parentheses. After else if we have something we're checking in the parentheses. But after else we don't have a parentheses, and that's just because else just means everything that doesn't match the first two conditions. And so we don't need to explicitly state a condition after else, right? So if the first one is if 9 is greater than 8, do this, else do that. That by definition means as long as 9 is not greater than 8, we'll do the else. We don't need to write else if 9 is less than 8 or something else, right? We don't need that additional detail because else just means if the if condition was not met, then we do the else. Does that make sense to folks? Or rather, are there any questions? Hello, another question. So someone unmuted. Okay. So then the last thing we'll talk about today is then this idea of, well, what are we actually checking, right? So far I've put here if 9 is greater than 8, and then afterwards I put down if num is greater than 8. But really, like, what does it mean to check? And so remember how I said on the very first day, right? Computers are very good with precise things. They're bad with ambiguities. The easiest decision for a computer to make, and really what the computer is, like every time you give a computer a command, all it's trying to do is break it down to one simple decision, like yes or no, true or false, go or no go, right? Like having two options is the easiest decision, theoretically any decision maker has to make. And a computer is always trying to break down its decisions into a yes or no, into a binary state. And so in order for us to do that, one of the things that makes it really easy for us to really get there is this idea of booleans, which we talked about on Wednesday, right? Remember, booleans are a data type that only has two possible values, true or false. And when we deal with something like an if-else loop, the if loop, we always want that thing in that statement to basically tell us, are you true or are you false? Now, sometimes it's something very simple, very mathematical, right? In the previous page, we saw the example of if 9 is greater than 8. Well, that's just true, right? It's a true math statement, and so we mark that as true. But the other thing we'll also notice, and we'll talk about not this side, but the side after, is what happens when something is truth-like, but not quite directly true. And so how do we check if things are true? Well, we do it through kind of somewhat very basic mathematical comparison operators, right? So in JavaScript, the way to check whether or not if two values are equal is with 3 equal signs. Okay, I'll say this now, and if someone on your team forgets, please remind them. This is a very big thing that people get tripped up a lot. Whenever you use 1 equal sign in JavaScript, it's not a comparison operator. That's an assignment operator. Right? If you know how on Wednesday when you guys created all the variables, you said let number equal 6, right? Or let my name equal David, or let blank equal blank, right? There you're only using 1 equal sign, and when you use that equal sign, that is saying take whatever value is on the right hand side and give the variable on the left hand side that value. Right? That's an assignment operator. In JavaScript, for us to check two things, we actually use the 3 equal signs. The triple equal signs. There is a double equal sign in JavaScript. We highly recommend you not use it. I won't go into too much detail why, except that it doesn't compare things the way that we intuitively think about comparing things. It makes assumptions for you that could sometimes be counter to what you want. And it's a good rule of thumb, generally speaking, in most programming, in JavaScript at least, people only use the triple equal signs. Okay, so the triple equal sign checks to see if two values are equal. And then having the exclamation mark and 2 equal signs checks for, what that tells us is if one or two values are not equal. The exclamation mark in JavaScript stands for bang, B-A-N-G, or it's called the bang symbol, and it basically means not, or the opposite of. And so exclamation mark equal basically means if these two values are not equal, give me true. If they are equal, give me false. And then beyond that, we have some of the more standard ones that we remember from kind of earlier math, right? The less than operator, the less than or equal to operator, the greater than operator, and then the greater than or equal to operator. These are all kind of very simple math comparisons, and so hopefully we've all seen them before in some context. Um, and so here's like the part where we're talking about how if something when we talk about an if statement, right? The only thing that really kind of matters to us is that statement next to the if statement, is that true or not? But sometimes it doesn't have to be true. It can be truth-like or truthy. Truthy is a concept in JavaScript that we'll talk about more in the full-time curriculum. But just know that most values in JavaScript are truthy. And so things like I am, like any string that has characters in it is truthy. Any number that's not zero is truthy. Any array or any object are all truthy, right? And in fact, the universe of truthy things are so much. It's often much easier for us to figure out what values are not truthy or what values are falsy or false-like. And so the only false values that exist in JavaScript or false-like values in JavaScript are empty strings, the number zero, nulls, undefined, this thing called NaN, which stands for not a number. And you'll see that probably not today, but maybe later on. And then obviously the false value itself. Okay. The reason why this is a big deal to us is because remember, in an if statement or any conditional statements, when we're checking for something, all we're really checking to see if the thing in between those parentheses if is true, right? And so now we basically have a framework for saying, give me any value in JavaScript, and I can tell you if this value is true or truth-like or false and false-like, right? By being able to convert any value in JavaScript to either true or false, what we've done now is we've basically taken any value in JavaScript and said, I can now empower you to make a decision on this variable because this variable will either be true or it'll be false. Okay, the reading probably will give you a little more detail around kind of truthiness and falsiness, but for our purposes, all I really want you to know regarding this is just that all values in JavaScript can be classified as either true or false. And the reason why that's important is because whenever we need to make a decision in JavaScript on whether or not to do something or not do something, we're essentially taking a value and boiling it down to either true or a false value. Okay. Then a few other operators are going to come in handy. One is the exclamation mark or the bang operator. This basically means give me the opposite of whether the value is true or false. And so in this case on line 4, this value is true. So is that true? Yeah, it's true. And so give me the opposite of that, which is false. If I have the string ABC, is that true or is that false? Well, the string ABC is true because the only false string is an empty string. And so the exclamation mark says give me the opposite of that string, which will be false. Similarly, all numbers are true except for 0, which is false. So this is definitely a true number. And so the opposite of that, or bang 100, is going to be false. And then the opposite, and then all arrays and objects are true. And so the opposite of any of those is going to give me back a false. Right? And then to make things just a little bit more confusing, we have the double bang operator, right? We put 2 of these in a row. So you can think of this as the opposite of the opposite. That's very kind of mind twisting, and I think folks sometimes struggle with that. So in my mind, the easiest way to think about it is just, hey, if I give you a value, the double bang says, give me the opposite of the opposite. Well, that kind of takes you back to where you started, right? So this is basically saying is, hey, is this value true or false? And then that's pretty much it. And so if I say, hey, for this true value, if I see 2 exclamation marks in front of it, that just says, is this value true or false? And it's true. Similarly, with a string ABC, is this string ABC true or false? Well, once again, it's a non-empty string, so it's true. 100, well, it's not 0, so it's true. An array or an object, those are always true. And so whenever you see 2 exclamation marks or double bangs in front of a value, all we're really saying is, hey, just is this value true or false? In this case, everything on this page is true. The last 2 things I'll talk about before we wrap up are also some additional logical operators. So the first one is called and you write it with 2 ampersands. What and does is and allows us to check multiple values in sequence to see if they're true or not, right? If I say go to the store and buy me milk and bread and juice, well, I need all 3 things, right? If you only come back with just milk and juice, you didn't really kind of follow the orders that I gave you, right? And so when you think about and, you can think of it as a way for for JavaScript to check multiple things in the order in which you give it. And so on line 4, what this is saying is, if I look at the right-hand side of the equal sign, this is saying check if 10 is true. And if 10 is true, then check the next thing, which is 10 and the string apples. Well, so 10 is true, so then we check apples. And then apples is true, so then we check the next thing, because there's another AND operator after apples. And the number is 0. 0 is not true. And so at that point, the AND operator just stops and says, okay, I found your first non-true value, which is 0. Similarly, on line 7, we do the same exact thing. We check the string lucky first. Is that true or not? That's true because it has characters. So then we check the next. So then we do that. We see the AND operator and we check the next value, which is the string number. Is that true or not? And that's true because it's a string with characters. And then we check 7. Is that true or not? That's true because it's not 0. And then we've reached the end of our checks and we've said, okay, I've checked everything in the sequence and everything came back true. So then I'll just give back the last true value, which is 7. Okay, so AND is a way for us to check multiple elements in sequence going from left to right. And as soon as we hit the first non-true value, we'll say, hey, here's your first non-true value. Or if we make it to the very end, we'll say, hey, here's the last true value that we found. Then the converse of the AND operator would be the OR operator. So if I say go to the store to give me milk or juice or bread, right? Now if you come back with either one of those things, I'm pretty happy. And so the OR operator is written comes with two vertical lines called the pipe symbols. If you look at your keyboard, they're probably they're probably under the backspace key under most keyboards. What the OR symbol is, it works very much like the AND operator. It still checks from left to right in sequence, except now it's doing the opposite of AND. Whereas AND required everything to be true, or just requires at least one thing to be true, right? And so when the OR operator goes from left to right, it will stop at the first positive or the first true value that it finds, right? And so on line 4, the first value it checks is null, which is false. So it says, okay, I'm going to keep going because it's or the next value. Or the next value is undefined. Well, that's also false. So let me check the next thing. Or the string happy. And it says, okay, great, the string happy is true, therefore I found the first true value, I'm done. I don't need to check the fourth value because I know at least one thing in this sequence is going to be true. And then similarly on line 7, false is false, so then it says, or let me check the next value, which is null, that's also false. Or let me check the next value, which is 10 less than 0, and the answer is no, that's false. So it says, or let me check the last value, which is not a number, and that's also false. So only after it checks every single value does the OR operator say, okay, great, I've checked every value, none of them are true, so therefore I will give you back the last false value that I found. So once again, it works just like the AND operator in that it goes from left to right. It checks a bunch of values in sequence, except whereas the AND is looking kind of for the first false value, so it can tell you, hey, not everything here is true, or it's checking for the first true value, so it can tell you, hey, at least one thing in this sequence is true. And that's all I have for today. So are there any questions before we get started on the workshop? Not a lot of slides, but this is something that it might take some time for you to kind of wrap your minds around. Any questions at all before I divide this up into pairs?
I'm looking on my Mac and I can't find the OR.
You can't find the